Good morning, dear students. So we are going to solve question number 7 of exercise 1.2. In that question, if you see in your textbook, you will find that you justify whether this function f from R to R means don't take it to be relation, it's a real number. F is a function from real number to real number defined by, this is the definition, fx is equal to 3 minus 4x, this is the definition. And now we will see whether this function is 1 1 and onto or not. Okay, so if we see carefully, now first we will see whether this function is 1 1 or not. 1 1. Yesterday in my previous video, in my previous class, I told you that the definitions of 1 1 function and onto function. So now we are going to use the definition of 1 1 function. It was said in the definition, it was said that a function is said to be 1 1 if f of x1 is equal to f of x2. If f of x1 is equal to f of x2 implies that x1 is equal to x2, then we can say the function to be 1 1. Okay, now what I have done, I have taken two elements of this R. So I have written, means the domain, this is codomain. So I have written let x1 x2 belongs to R such that these two are equal. The image of f of x1, image of f of x2, they are equal. If the images are equal, then the element has to be equal to be 1 1 function. So images are equal. So I am using here definition f of x1, f of x is equal to 3 minus 4x. So f of x1 is equal to 3 minus 4x1. I have written 3 minus 4x1, 3 minus 4x2 using the definition. So now this is simplification. 3 will go out. Then after getting that, we will get minus 4x1, minus 4x1, minus 4 also we will get. Finally, we will get x1 is equal to x2. So what we have started with this one, we have started with f of x1 is equal to f of x2. What does it imply? That x1 is equal to x2. So if the images are equal, then the elements are also equal. That means the function is 1 1. So this is the easiest example, easiest question to solve. So I have taken up the first question to be this one. So we have already proved that it is 1 1 function. Now we will have to show that this is an onto function also. How to show that onto function? While defining onto function, I said that the definition is very easy to understand, but while solving we may face some problem. Okay, I'll try to make it clear to you. So onto function means every element of this set must have a pre-image, means every element must be associated, must be connected to some element of this set. So if we let us take let y is any element of codomain. This is an element y I have taken from here, and I will show that for y there is some element here. Then if I can show that for this y there is some element here, then I can claim that it is onto function. Okay, such that f of x is equal to y. F of x is equal to y. Okay. Now here, what is fx is equal to? I have not said what is x. Where is x? No, where? This is my solution. I have not defined what is x now. Finally, I will show that this x belongs to this set. Okay, that's my aim. So f of x is equal to what? 3 minus 4x is equal to y. Now let me find out what is y x is equal to. X is equal to what? See, y, this 3 will go in this way. Y minus 3 divided by minus 4. Or I can say 3 minus y divided by 4. I will write it as 3 minus y divided by 4. Now what is x is equal to? It is 3 minus y divided by 4. Now see, y I have taken, it's an element of codomain. That means what is the codomain? A real number. That means y is a real number. Now a real number is subtracted from 3. A real number is subtracted from 3. So what about this one? This is also a real number or not? A real 3 minus a real number is a real number. That means this is real. 4 is a real number. A real number is divided by a real number. Again, we are going to get a real number. So ultimately, this y, 3 minus y, this is a real number. This is a real. This is real. I have not said here domain, codomain. I am writing here real. So this is real. If this is real, what about x? X is also real. And if x is real, that means x must be here. Hope you have understood. Once again, this is a real number. This is a real number. So if this is real number, then x is also real. And if x is real number, then x must belongs to the domain also. It will definitely, x will be here also, but that is not our lookout. X belongs to this set also. That means what? For y, there is some real number in this set such that f of x is equal to f of y. That means what? This y has a pre-image here. If y has a pre-image x, that means every element of this set has a pre-image. So it is a onto function. Hope you have understood. We'll see some more example in the next video. Thank you.